Hello. Good evening, everyone. I'm Shafali Gawal. I'm a research scholar at IIT Madras in Civil Engineering Department. So, this is our fourth TA session on the topic of basic construction material. In last week, we have started talking about the nature of materials, and where we have talked about the basic material concepts about the different type of electronic configuration, what are the different type of bondings available, and in metallic materials how lattice structure and lattice defects, what are the different type of defects are there in our material. And in this week we will talk about the inorganic and organic solids. This is also a part of nature of materials, and we will talk about different type of materials, mainly inorganic and organic solids. And then uh, we will start with the first type of materials, and those are the stones, bricks, and mortar. So, a little overview of week 4 is like, first is the different type of inorganic solids. So, what are the inorganic solids? They are the type of non-metallic elements or a combination of metallic and non-metallic elements. Normally, they are also called as ceramics. So, one of a few examples, these inorganic solids are mostly having covalent and ionic bonds. So if we take an example, in case of covalent bonds, we have diamond, which is a type of inorganic solid, and in case of ionic bonds, one example is our normal Portland cement, which have a tetrahedral structure of silicon. Okay, and there are different classes of these inorganic solids. So they can be glasses, they can be ceramics, concrete, cement, then rocks, minerals. These are the type of inorganic solids. Second thing is, what are the organic solids? So organic solids, if we see in this case, the organic solids can be defined as the long molecules of covalent bonded carbon atoms. So when we have long chains of carbon, long carbon chains, those type of materials are normally called as organic solids. So they are uh, long carbon chains which have like if CH, carbon and hydrogen, long chains of carbon and hydrogens. So a connection of multiple chains like this are called as organic solids. So normally different organic groups can be attached to this uh, chain, which can be some organic heteroatoms, or it can be some other organic materials like hydroxides, amines. So those are also called as the part of the organic solids. So if we talk about the inorganic solids, there are different type of structures in our material, and main of them which we are talking about here is polycrystalline structure. So crystalline structure, we all know, where all the atoms are in a symmetry, they are attached in a symmetry or in a defined parameters. In amorphous, atoms are randomly oriented. However, in polycrystalline, what is happening? There are grains. A grain will be formed, which will be a combination of crystalline structure. Then there will be another grain, and all these grains, when attached together, they will form as a polycrystalline material. So this, if we talk about, this is our grain boundary, and this is one grain, and within a grain the structure is crystalline. However, if we see the complete structure, it will be, if we talk about the different grains, it will be a amorphous with respect to grains, and within a grain it is a crystal. So that's why we are calling it as a polycrystalline material. So next thing is, in organic solids, we are dividing our organic solid in three types: thermoplastic, thermostatic, and elastomers. So what is first thing is thermoplastic. So if we talk about thermoplastic materials, so what are the thermoplastic materials? They are the normal long carbon chain which are not linked to each other using any cross linking. So they are just long carbon chain attached together, and they uh, upon heating, what will happen, these secondary bonds can be break easily, and material can be melted. So these are the few example of our thermoplastic material. It can be, if we here we will see some polypropylene or some PVC pipes. So these are few example of our thermoplastic which can be easily melted. And next thing is thermosetting. So what are the thermosetting? Thermoset material. Thermoset materials are the carbon chain which are cross linked with each other. So there are carbon chain which are linked to other carbon chain using a cross linking, and this, because of this cross linking, the material behave as an elastic material. So few example is like epoxy resin, and then we have a polyester. So these are the example of thermosetting materials. Last type of materials are elastomers. So what are the elastomers? They are linear polymers with limited cross-linking. So cross-linking is there, but it's not as complicated as in thermosetting material. So they are actually more elastic as compared to the thermosetting materials, and because of this cross-linking, the elasticity, the material, when it is under force, it will change, it will deflect, but when the force is removed, it will come back to its original shape. That are called as a elastomers. So if we see a normal rubber bands and all, they are that example of elastomers. Next thing you might have studied in this week would be the melting and glass transition temper. So So melting and glass transition temper is when polymers, reaction of our polymers to temperature, then it will depend on the degree of crystallization. So that if we define a normal material, if normal polymers are there, they have a very fairly defined transition between elastic and viscous behavior. However, what happens at higher temperature, this, because of this vibration, there is a separation between the elastic and viscous behavior. So upon cooling, the molecules will the motion of molecules will decrease, and the viscosity of the material will increase it. So at there is a temperature, glass transition temperature. What is the exact definition of glass transition temperature is when the molecules are no longer free to rearrange and their position are fixed, and the free volume becomes zero. At that point we are telling it is like, sorry, it is, that temperature is called as glass transition temperature, when the it cannot come back to its original shape. That is a glass transition temperature. And below this glass transition temperature, there are mostly secondary bonds will be there, and above this glass transition temperature, our material will behave in the elastic way. Okay, and uh, next thing is the if in we come to this polymers only. So other thing about polymers is the what are the different mechanical properties of our polymers. So it depend on, like, if we have talked about three type of polymers were telling: thermoplastic, thermosetting, and elastomers. So how different properties are it is a a comparison of elastic modulus with respect to covalent bonds. So if our bonding is very weak, the elastic modulus is low, and as our covalency is increasing, elastic modulus is also increasing. So this is a normal graph between for polymers, different between elastic modulus and fraction of covalent bonding. So this is what we call as a little summary of inorganic and organic polymers. Other thing which is started in this week is the different materials. So if we talk about the first material which had been started in this lecture is first material which is started in this lecture is about the masonry. So in masonry, there are three different type of masonry we usually say: brick, brick, laterite, and hollow block. So it can be made of clay, it can be made of mortar. So those are the mainly materials which we are currently using to make our masonry structure. So if we say first thing is about the clay brick. So clay brick you all have already might have seen while making walls and all in a structure. We are using this normal orange color clay brick. And what is the different mechanism how this clay brick is formed is given here. First we collect the clay, and then that clay is grinded properly, and then this clay is mixed with water, and it is molded and different. After molding it, we are keeping it in we are drying it, and after drying, it is kept in the kiln. So it is a very big kiln. I think you might have seen that photo in the first lecture already. And we are keeping it in kiln, and then we are cooling it out, and then we are delivering it. So that is a normal mechanism of how a clay brick is formed. So what are the different type of clay bricks usually present? Different type of bricks exactly. One is sun-dried brick. So after keeping in kiln, either the bricks will be dried normally under the sun, or it is burnt clay bricks. Burnt clay bricks means the kiln temperature of burnt clay bricks will be more, and while drying process itself, the temperature will be very high. So what will happen? The bonding will be very strong in burnt clay bricks as compared to the sun-dried bricks. Other type of brick is fly ash bricks. So these are the what we'll say new type of bricks which are coming up using the uh, SCMs, normal cementitious materials, supplementary cementitious material or waste material. Using those type of materials in our brick, we are making fly ash bricks. And last are the concrete bricks. So using our concrete material, normal mortar mixed with aggregates, we are making the concrete bricks. Okay. So other thing is what are the when we are constructing structures, sometimes we have to break our brick in different type, in different form. So what are the various form of brick portion is? Now, our brick look like this. If we are breaking it longitudinally, it is called as screw enclosure. And if only 1/4 part of our brick is used, that is called as screw enclosure in quarter. Then if a triangular piece is cut, a triangular piece is cut from one corner, it is called as king closer. And if it is cut in this way full length, that is called as beveled closer. And if it is cut in along the width, then it is called as mitered closer. Same way, it is called as bat if it is cut along the width, then it is called as half bed, three-quarter bed, beveled bed. So these are the various form of bed portion. When you are doing masonry work, you usually use these terms. Next thing is efflorescence of bricks. So why does efflorescence happens in bricks? Any idea? So okay, presence of salts, correct answer. So mainly because of salt and because of moisture, the sulfates will form. The sulfates will react, and this white patch will be formed over our bricks. So that is called as efflorescence of bricks. So because sorry, that salt will be mainly due to the presence of that salt will be coming from the water mainly, and when these salts will react with the brick material, the sulfates will be forming. Mainly for magnesium, calcium, sodium sulfates will be forming, which are called which form this white patches over our brick surface. So after this, what are the different type of bricks which we are using in India mostly is, sorry, it's not type of bricks, it's type of stones. Okay. So next thing, this is a little overview about the bricks. Next thing is the stones. So what are the different type of stones which we are using in India mainly are the granite, marble and red sandstone. And if we come to the third thing is the about the mortar. So what exactly is the mortar? Any idea? So when we are mixing a binding material and sand, we are calling as a mortar. So if we come into our concrete industry, if we are mixing cement and sand with water, that is we are calling it as a mortar. So common binding material used in masonry are cement, then we are using lime also, gypsum and clay. So these are the different type of binding material which when added with sand and water will form the mortar for our system. So what are the different terms associated with masonry? So if you might have seen any wall work in your locality or any construction site, so these are the some terms which we are usually using. First is the header. So if this is a brick, if this is a normal brick, and this part is called as header. So this is our vertical joint, then this is bed joint. One layer above other layer, when we are keeping the joint in between those two layers is called as bed joint. And one brick and other brick when joined, the brick joint between these two bricks is called as vertical joint. And then this part is the stretcher. So if a brick is kept in longitude, sorry, along this length it is header, along this length it is stretcher. Okay. And one layer it is called as the course of our uh, masonry. So these are the some important terms which are associated with masonry. And if we see in a complete, like if it is a complete cross sectional area and we see different terms, so if we start from the bottom, we have foundation, and above foundation we are keeping our footing, and then we have our plinth level, plinth beam or floor level, and then we have our window sill. Above window we have chhaja or sunshade, then lintel beam. Lintel beam is mainly provided at the we say at the top of the door area, that is called as that that beam is called as lintel beam. And then we have string posts, parapet wall, normal wall. Coping is like a roof, and sorry, above roof we are providing sunshade type of thing, that is called as coping and roof. So these are the various elements of a normal cross sectional area of any structure, mainly masonry structure. And then if we see recent section through wall, modern section, then we are having many other different type of things. We are using reinforcement in them, and then we are using, instead along with normal bricks, we are using concrete bricks, hollow concrete bricks, and we are using reinforcement in that, and then we are using waterproofing materials. And here we are providing weep holes so that moisture does not get inside our structure. And uh, other thing is like we are providing foundation and sealing to the sealing to the foundation, so that there is no capillary action of the water from the bottom. And many other things are there, so you can read about it. Other thing is, if we talk we were talking about mortar. So when we are applying mortar, how we are applying mortar, we are putting one brick, we apply mortar here, then we are applying mortar here and kept the other brick, and then next brick same way, then we apply mortar at the complete surface and keep the another layer in the same way, right? That is a usual practice. So here they are showing the different how mortar is applied to the different joints. So this is the correct procedure of how the mortar should be applied. Should it be applied on the brick or should it be applied on the surface, and how to keep it, and those things. So when a joint is formed between two bricks, mortar joint, so normally if we are using very strong mortar, what will happen, there are chances when load will be there, this mortar will not allow the material to slip properly, the bricks to slip properly, and there will be a chances of failure in this case. So usually we are providing some joints into a mortar. So these are the different type of joints which are provided in the masonry mortars. So concave, V, weathered, so based on their shape and type of joint, we are providing different mortar joint. So these type of joint are mainly provided to relieve the stresses, and so that if earthquakes or any damage is there, these our masonry structure does not damage. Okay. Next type of masonry is, that was brick masonry, mortar masonry. Next type is rubble masonry. So here we are using some stones type of material, stones mainly, how stones can be kept and make a masonry. So mainly if you might have seen some old temples and all, in those kind of area we are using this type of, it has been used this type of masonry. And maybe some zoo or and those kind of area you will see this type of pathway, uh, and then walls and all. Mainly they are used in outside wall, not as a structural element, it's mainly for the decoration purposes, or just an what is say boundary walls. So they are the different type of rubble masonry which are being used, flint, ash, and different class of rubble masonry, second class, first class, third class. So these all are just the terminology which you might not need required, mainly just for the knowledge purpose. Next thing is the, in bricks only we are having different type of bonds. So main type of bond is are stretcher bond, Flemish bond, and English bond. So what we are doing, if this is a brick, this is a normal brick. If we are keeping one brick, another brick, and on top of that, at the center of this another brick, center of this another brick. In this way, we are keeping a brick that is called as stretcher bond. Then, if we are keeping a brick like one brick in this way, one brick in this way, then one in this way. If we are keeping in this way, then we are calling it as a Flemish bond. And if we are keeping one layer of straight and then one layer in this way and then another layer in this way, that is called as the English bond. So these are the three type of brick bonding which we are using. Most of the time you might have seen people using English bond, like two bricks in this way are kept, and then another layer will be like two bricks in this way. So majorly English bond is used, and if we see outside wall which doesn't carry any load, that time we are using stretcher bond. Okay, so these are the different type of brick bonding which have been used. And next thing is concrete blockade. So instead of using normal mud or what we say clay or stone, when we are using concrete material or we are using cement in our bonding, that time cement in our bricks, that time we are calling it as a concrete block. So they are the various shape of concrete blocks which are used. And if we see a normal concrete block, a hollow concrete block, so why we are providing hollow concrete block? First thing, it will reduce the weight of our this say complete structure. Second thing, mortar filled in this one will have a good bonding with the other material. Even in our normal brick also we are providing a space which is called as frog at top, so that mortar will sit properly. Other thing, if we are to use a reinforcement into our wall, these type of hollow blocks will be better in case of providing reinforcement. So these are the different type of concrete blocking. And these are the so we have studied different type of masonry. We have studied brick masonry, stone masonry, mortar masonry, sorry, concrete masonry. Other thing which have been used are the composite masonry. So if we are using two or three type of these masonry together, that is called as composite masonry. So in this case they are using stone along with brick, same way stones and brick masonry when used together. And other thing can be like in the first example we have seen bricks were used along with the concrete block, so that is also a type of composite masonry. So this is all what you might have studied in this week. If you have any doubt you can ask me now, otherwise we will go to the question and answer session. Okay, if there are no doubts, then we'll go to question and answer. So first question is, burnt bricks have higher compressive strength as compared to unburnt bricks. It is a true or false? Anyone who want to guess the answer, you can type in chat box also. Okay, we have already discussed this thing. In burnt bricks, actually burnt bricks have a higher compressive strength as unburnt bricks. So, what is the reason? Because of the heat from the kiln. What will happen? Moisture will, there won't be any moisture, and the burning will cause a chemical reaction within the clay particles, which will fill up the pores in this burnt glaze, and as compared to this unburnt glaze. So unburnt glaze will be more porous, and won't have even there will be some chemical reaction because of this burning processes, and because of that it will be much more stronger than the unburnt glue. Okay. Okay, so second question is, which of the following is true for the Kuhn closer modular brick? So first thing is, if we see any modular brick, what is the dimension of a modular brick normally? We'll see this example only. Normal modular brick will have 190 to 200 mm of length and 100 or 90 to 100 mm of width, and same way height will be 90 to 100 mm. So if we are talking about tune closer. So in tune closer, what we are doing, we are cutting our brick in the half, in the along the length. So what will happen? Length will be same, 20 centimeter, but width will be decreased by half, 5 centimeters. So answer will be A. Okay. Okay. So the third question is, consider the following three statements. Lime hardens by absorbing atmospheric CO2. Non-hydraulic lime mortars are not generally used in substructure. Lime mortars are generally designed weaker than masonry units. So which of the following is the most appropriate answer that best describes this statement? A and B are correct, but C is incorrect. A, B, C are all three are correct, and C is the proper reasoning for B. B is incorrect, A and C are correct, and A is the proper reasoning for C. B is correct, A and C are incorrect, A, B, C all are correct, and A is the proper reasoning for B. Anyone? Okay, we will go by statement by statement. First statement is lime hardens by absorbing atmospheric CO2. So when lime actually reacts with CO2, what will happen? We are forming calcium carbonate. So calcium carbonate are actually solid particles. So when lime react with CO2, it will hardens and form calcium carbonates. So because of this carbonation, this statement is true. Second statement is non-hydraulic lime mortars are not generally used in substructure. So if we talk about non-hydraulic, normally lime mortars, non-hydraulic lime mortars, what will happen? uh, in in substructure means in foundation normally. So in foundation we have a lot of moisture. So if we use non-hydraulic lime mortars, what will happen? These non-hydraulic lime mortars, they won't harden or they won't set when they react with water. So this type of lime mortars are not generally used in substructure. That statement is also true. Third statement is lime mortars are generally designed weaker than masonry unit. So we have already discussed. Normally we are designing our mortar which should be weaker than our masonry units. Why? So that it can what we say absorbs stress. It has stress absorption, and also it will allow the movement between different brick unit. So if this is a lime mortar, its strength will be normally weaker than both of our masonry units. So all three statements are true. Okay. So ABC is correct. ABC is correct. So, what is telling? C is the proper reasoning for B. Lime mortar generally designed weaker than masonry is not a reason for not using it in the substructure. And A is the proper reasoning for B. So this is the correct statement because since lime hardened using CO2, so that's why we are using lime in the superstructure, not in the substructure, because in substructure normally we have water, and what lime won't set when it react with water, it will set when it react with CO2. So the statement is correct. Okay. Okay, then we'll go to the next question. Match the masonry structure parts in column A to their definition. So different masonry structure parts are jam, plaster, pier, coping. Freely standing column, sides of the window opening, covering of the parapet wall, column attached to the wall and projection wall. So all the terms are given here. If we see uh, what is a jam. So this is a jam. It is in the window area, sides of the window frame. So jam is side of the window frame. Next is pilaster. So is plaster given here? Plaster is not given in this part. And next is the pyre. Pyre. So pyre we might have studied in footing and all. The pyre is normally a column is called as pyre, that we all know. Right. Last option is coping. So coping is the this one, covering of the parapet wall, right? Our parapet wall. So coping is covering of the parapet wall, and pilaster remaining is it is a column attached to the wall and projecting beyond. So it is not given here. So the correct option is A second, A second, B4, A second, B4, C1 and D3. Okay. If you have any doubt, you can ask in between also. So next question is, which of the following is or are the correct reason to pre-soak bricks before placing? So normally, if you have seen in any site, we will keep our bricks in water, and then only we'll start putting it mortar above it. So why we are doing it? Because pre-soaked brick will have higher compressive strength. They will absorb less water from the mortar when compared to unsoaked brick. They have low coefficient of thermal expansion, or they have a better resistance to abrasion. So this is very simple question. So what, when we are keeping brick, we are putting it in water so that all the pores are filled with the water. So whenever we are placing mortar above it, that it the brick will not absorb the water from the mortar, and mortar can set easily uh, or hydrate easily without giving the water to the bricks. Okay. So the next question is, in a newly constructed structure, all the electrical wires are housed in a conduct made of amorphous polypropylene. There was an accidental short circuiting. Which of the following is true regarding the conducts? So glass transition temperature is minus 17 degrees Celsius and melting point is 176 degrees Celsius. The conduct behaves like a viscous liquid at temperature above 176. It behaves an amorphous material below temperature of minus 23. It enters into a glassy state at a temperature between minus 176 and minus 70. The conduct behave like a viscous liquid at a temperature below 17 degrees Celsius. So, what we told about Brand's transition temperature is temperature above which materials start behaving as an elastic material. right? So above minus 17 degree it will behave as an elastic material, and below this temperature it will behave as an amorphous material. So statement B will be correct. It will behave as an amorphous material below the temperature minus 23 degrees Celsius, or we can say minus 17 degrees Celsius. And other statements are, it enters into glassy state at temperature between 17 and minus 17 mole. It behaves like a viscous liquid at a temperature below minus 17. This is also not correct. It is behave like a viscous liquid at temperature. So above melting point, it will start behave as a viscous material. So answer are A and B. Okay. Okay, so the next question is, how do grain boundaries in polycrystalline materials affect the mechanical properties of material? So we all know about polycrystalline materials. They are made of different grains, and inside grain it is crystalline, and outside grain it have some grain boundaries, make it amorphous, not amorphous, polycrystalline. So they make the material weaker by providing easy slip path. They strengthen the material by restricting dislocation motion. They have no effect on mechanical properties. They only influence the electrical property, not mechanical. So because of this grain boundaries, what will happen? It will strengthen the material. So the grain boundaries will act as an obstacles to dislocation movement, increasing the material strength. Okay, so the answer will be B. Okay, so we'll go to the next question. It is match the following. We have thermoplastic, thermosetting, and elastomers, and these are few examples. So what are the different example of thermoplastic material? So what were the thermoplastic material? We have the carbon long chain, which doesn't have a which have a weaker bond in between. So we all know we'll call polythene as a plastic, right? So thermoplastic, one example is polyethylene. The next example was PVC, which we usually use for pipes and all. That is also we call as plastic material. Next is thermosetting materials. So thermosetting materials were the materials which were cross-linked and were in the random area like this. That is the thermosetting materials. So example of thermosetting will be, so bakelite is one of the example of thermosetting materials, and epoxy resin is the example of thermosetting material. So it will be when it hardens, once it hardens, it's difficult to go back to the elastic stage. That is the thermosetting materials. Last is the elastomers. So elastomers are actually normal carbon chain in some pattern which are cross-linked in another cross-linked properly, and it is elastic in nature because of this cross-linking. And one elastomer or elastic material example is natural rubber. Okay, so the answer will be B. Okay. Okay, so this is the last question for today. What is the primary difference between thermosetting and thermoplastic polymers? So this is a thermoplastic polymer, this is a thermosetting polymer. Thermoplastic are stronger than thermoset. Thermoset can be reshaped multiple times. Thermoset undergo irreversible curing process, while thermoplastic can be remolded. Thermoplastic have cross-linked structure, while thermoset do not have. So we have been talking about it for a long time, that thermoplastic uh, can be thermoset cannot be reshaped multiple times. It will be brittle once it hardens. And about stronger, so obviously thermoset will be much stronger than the thermoplastic material. And thermoplastic, it doesn't have cross-link structure. Thermoset have. So option is C, which is the correct answer. That thermoset undergo irreversible curing, whereas thermoplastic can be remolded. So thermoplastic can be melted and be converted into some other object. Normally plastics and all we did tell it can be recycled by melting. So that is a it, reversible process, or sorry, remold. It can be remolded. So that's all for week 4. If you have any doubt, you can ask in chat box now. Okay, if there are no doubts, then we'll close the lecture for today. Thank you for joining.